We're taking a look at wind and current problems. It's a logical extension from systems of equations problems. Now, the difference here is in a normal system of equation problem, you have the two equations written out for you, and then you have to just solve. Where in these problems, you have a word problem that you have to derive the equations from. So let's start with taking a look at how to derive some equations. We're going to let r equal the rate and w equal the wind speed. We're going to write an equation for these two sentences. The rate of a plane flying against the wind is 900 kilometers per hour. Well, we all know that the overall rate is 900. We also know that your rate, when you go against the wind, is going to be how fast you're going. That would be r, or your normal rate, minus the amount that the wind is pushing against you. So r minus w is equal to 900. In other words, your actual speed is going to be equal to how fast you can go under perfect conditions minus how fast the wind is blowing. Now obviously, when you're going with the wind, you're going to be adding the wind speed instead of subtracting it. No. 2. The plane takes 3 hours to fly 300 kilometers with the wind. Well, we know that rate times time is equal to distance. So let's plug in what we know. We know the time is 3. We know the distance is 3,000. And the only real trick here is, what is the speed of the plane? Now, we learned up here that the speed of the plane is going to be influenced by the wind. In this case, we are flying with the wind. In other words, the wind is giving us a push. So in this case, we are going to add w. And then we have the rate that we normally would go. And so this part here represents my speed, my overall speed. Now obviously from this point I could simplify things a bit by dividing everything by 3. So a logical answer would be rate plus wind is equal to 1,000. So let's put this together into a problem that has a system of equations. A plane can fly 3,750 kilometers in 3 hours with the wind. The plane takes 5 hours to travel the same distance flying against the wind. Find the rate of the plane with no wind. Well, we learned that the rate with wind is going to be r plus w. And we know that it's going 3 hours, because we remember that rate times time equals distance, that's why I'm multiplying it. And the plane is going 3,750 miles. Well, when we're going against the wind, we learned up here that the rate is going to be r minus w times our 5 hours is equal to the same distance. So let's go ahead and solve this. First thing I'm going to do is I'm going to divide this by 3. Divide this side by 3. So my equivalent expression is going to be r plus w is equal to 1,250. Likewise, I'm going to simplify by dividing by 5, divide by 5, and I get r minus w is equal to 750. And now I have a system of equations. And not only do I have a system of equations, I have the added bonus of already having opposites. So w minus w is 0, right? So r plus r is 2r. W minus w cancels out. 1,250 plus 750 is going to be 2,000. That really is 2,000. There we go. Let's divide by 2, divide by 2. So the rate of the plane under perfect conditions, or still conditions, is going to be 1,000 kilometers per hour. Finally, these types of problems dictate tables a lot of the times. So here we have a canoe race where Colin travels 300 meters upstream and then returns. So he goes upstream, that's going into the current, so this is against the current. And then he comes and goes downstream, and that's with the current. Colin can paddle at a rate of 5 meters per second in still water. What is the rate of the rate of the current is 1 kilometer per hour, or 1 meter per hour. So his rate going against the current is going to be what he can normally hold, 5, minus the current of the water, which is 1. And so he is going to have a rate of 4 meters per second. Going with the current, on the other hand, he's going to have the 5 that he can normally hold plus the 1 meter per second current, and that's going to equal 6 meters per second. The distance is even easier. It just tells us that each way is 300 meters. And then here comes the time. Well, if I go 300 meters in 4, excuse me, at a rate of 4 meters per second, that's going to take me 75 seconds. I'm just dividing it. Whereas if I go the same 300 meters at 6 meters per second, it's only going to take me 50 seconds. So I was able to complete the table. But the big question is, why on earth would I complete the table? There's no real question for me to answer. And here is why. We can now find Colin's average speed in meters per second really easily. So let's go ahead and do it. So find average speed. We are going to have to know how far he went, so we need to know his distance. And his total distance is 300 plus 300, so that's 600. And we need to know his total time. So add up his total time, and he gets 125 seconds. Okay. Which means that his speed is going to be equal to his distance divided by his time, which is equal to 600 divided by 125, which is equal to 4.8 meters per second. So we've taken a look at how to create a system of equations using wind and current problems, as well as how to use a table to solve a wind or current problem.